Now, the third system is a circular system. That is the most important system. In this system, we are measuring an angle into the radian. So, how can you define the radian? Let that be the circle of radius r. That be the circle whose center is O, and that is the radius is r. We cut an arc AB whose length is equals to the radius of circle. So, the length of AB is equals to r, where r is the radius of circle. So, that length OA and the length AB both are same. So that arc AB subtend an angle at the center, that is the angle AOB, is called the 1 radian, represented by 1c. So the definition of 1 radian is what? In a circle COR, where O is the center, R be the radius. Cut an arc AB is equals to the radius of circle. So the angle AOB is equals to 1 radian. That is the definition of the radian. Now, important result is that after 1 radian definition is that important result, let that be the circle COR. OA be the radius, O be the center. Let the radius of a circle is R. Where O is the center, the radius of circle OA is equals to R. We cut an arc AB whose length is what? S1. So that AB arc subtend an angle at the center is θ1, not equals to the 1 radius, because the length of AB is not equals to the radius of circle. The length of AB is what? S1. Both are different values. So the angle AOB is θ1. Cut another arc AC whose length is what? S2. Cut another arc AC whose length is S2. Again, that AC length is not equals to the radius of circle. So angle AOC again is not equals to 1 radian, is equals to the θ2. I repeat again, 1 radian is the definition when the arc length is equals to the radius of circle. So we have get here the another important result. In a circle COR, O is the center, R is the radius, AB length is S1, angle AOB is θ1. Cut another arc AC, length is S2, so the angle AOC is S2. So the important result is that the ratio of the angle subtended by an arc, is proportional to the length of their corresponding arc. So the angle AOB corresponding length is AB, angle AOC corresponding length is AC. So the θ1 upon θ2, that is θ1 upon θ2 are the angles, and the length is S1 upon S2. That is an important result. Now again, we are getting the another result is that prove that angle equals to arc upon radius. That is the formula. How we get that formula? By a trigonometry. Angle equals to arc upon radius. For that, we are making a diagram. Let COR be a circle in which O is the center, R be the radius. Cut an arc AB whose length is equals to the radius of circle. AB length is R. Here we can, I repeat again, O is the radius and the length of arc AB again equals to the radius. So the arc AB subtend an angle at the center is 1 radian. AB radius equals to the radius of circle. AB length is equals to the radius of circle. So the arc AB subtend an angle at center is 1 radian. Cut another arc AC whose length is not equals to the radius. Let the length of AC is S. I repeat again, the length of AC is equals to S, not equals to the radius. So the arc AC subtend an angle at the center is θ. Explain the diagram again, that the AB arc subtend an angle at the center is 1 radian, because the length of AB equals to the radius. But the arc AC subtend an angle at the center is θ, because the length of AC is S and the length of radius is R. Now, in previous result, by the definition, we know that the ratio of the arc, the ratio of the angle subtended by an arc at the center are proportional to the length of their corresponding arcs. That be the angle AOB subtended by the arc AB. That be the angle AOC subtended by an arc AC. So the ratio of the angles subtended by an arc at the center are proportional to the length of corresponding arcs. So the angle AOB is 1 radian. In that diagram, 1 radian. And angle AOC is θ. length of AB is R and the length of AC is S. We can cross multiply it. We are getting here theta upon 1 radian equal S by R. Taking the alternate rule, theta upon 1 radian S by R. Okay, now cross multiply, theta is equals to S by R into 1 radian. And 1 radian multiplied by 1, S by R are no change. So theta equals to S by R, where theta is the angle, S be the arc and R be the radius. So we get the relation angle equals to arc upon radius.